So we're going to begin by opening our Kali Linux machine and opening our terminal. From there, we're going to SSH into the server using our username narnia0 at narnia.labs.overthewire.org and our password of narnia0. Once we connect, we're going to cd into the Narnia directory. Once we've done that, we need to look at the actual program that we're trying to exploit. In our case, narnia0.c. To do that, we are going to end up doing cat narnia0.c. And the program's contents will get shown to our screen. So in this point, we can see the actual code itself. You can see it's a C program with our standard I/O headers and our standard I/O libraries. Notice the long value there, 0 times 41414141, and our char, our character, our buffer is 20 characters. So if we put something over 20 characters, we should be able to do a buffer overflow in this case because it'll be greater than what it's expecting. Notice in the program if the value equals dead beef, then it will give us a shell, bin/sh. So what we're trying to do is do an overflow and then write into memory the hexadecimal value of dead beef. So here we're going to execute the program and we're going to put in an input. In this case, I'm going to put a bunch of A's. I'm counting carefully to put 20 A's and 4 B's. What happened is I overflowed the buffer with the A's, and so the value got overwritten from 41414141 to 42424242, which was the hex representation of those B's. So at this point, I'm going to write a short Python script that will put 20 A's followed by the hexadecimal characters that I want, in this case, dead beef. Now I have to put it in a little bit backwards, and that's because of the fact that this machine is using first in, first out, or last in, first out architecture based on this machine. So in this case, I'm going to use the /ef/de/ad/de, and then I'm going to pipe that output into the narnia.c program, narnia0.c program. Notice my value has been overwritten with dead beef, just like we wanted. Now notice when I run this Python script, my value does change, but nothing else happens. I'm just returned to the shell, and that's because I executed the shell. Now what I want to do is have it so that when I execute the shell, it does something for me. In this case, I want it to show me what the password is for this stage, which allows me to go into stage 2. The way I'll do that is by using an echo command. And so in this case, I'll use the same Python script I used, then put a semicolon, echo cat/etc/narnia/pass/narnia1, which gives me the code to go into the next level, which would be narnia2's level. Then I do the pipe and run the program of narnia/narnia0. As you can see, my buffer gets overwritten. Dead beef is written to the value, which then goes to execute the shell, in this case executing my command, the cat of the password for narnia1. And I get the answer to the riddle, which was EFEIDIEDAE. If I go now to over the wire and use narnia1 as my username, and I use that as my password, EFEIDIEDAE, I can then go into challenge number 2. And that's just a very simple example of how a buffer overflow works. In this case, we overrode a 20-character memory allocation, pushing in those last 4 characters, whichever we put in there, into the memory, in this case matching up to cause an overrun to run our bin/sh or our shell.